Starting off with the presentation slides. Just wanted to introduce it very briefly. In case you didn't know, it was officially released, supported, announced during Google I/O this year. And it's actually already, I believe it's at 1.1 recently. So it's, as you probably know, it's a framework for, or language rather, for Android development. It's kind of the second language. And the typically what happens is that you create .kt files that contain Kotlin code, and when you create an application in Android Studio, you click the Kotlin support option. It's all done automatically, automagically for you. And I'll show you also how to do it from the command line. And there's some nice functionality. It gets compiled to bytecode as you would expect, and lots of nice integration. I think IntelliJ was the main proponent, supporter, champion, I believe, of Kotlin, and so it's got the integration you would expect, such as Gradle, when you create applications in Android Studio. So another sort of list of things that it does. I'm going to go through examples of some of these particular, the Lambda expressions and high order functions. Has anyone worked with either of those? Any familiarity? Okay, they're generally, it's interesting. If you've worked extensively with JavaScript, this is all familiar sort of stuff. It's been around for a very long time. And along with the functional reactive programming, which I would actually recommend that you start learning about functional reactive programming in a browser, because it's all there. You just have some script tags, you include it, reload your browser session. It's actually a lot more straightforward to do. You don't have to worry about setting up Android Studio and this and that. Things go wrong. None of that stuff. You'll immediately see the errors. So after you've done FRP in JavaScript, it's an easy transition over to Args Java, which is the foundation for Args Android, and also the Args Kotlin, Args Scala, and Args all the rest. So just as a kind of an FYI. Here are some other things they're not going to go into, but as you would expect, I'm sure, that it supports interfaces and inheritance. It's also got this new type of a data class, which is, I forget what it is in Swift. It's got sort of a counterpart in there as well. When you're specifically working in an Android Studio to create an Android application, you don't have to do the find view by ID. Some people are very happy, very excited about that. Either way works for me. I'm just so used to it now that it's kind of ingrained. So if it doesn't have really, really significant advantages beyond invoking that method, I'm like, it's like the binding options. What is that? I forgot who wrote that. Do you remember, Suresh? What was that binding? The alternative where you can embed method call invocations in the layout main.xml file. There's a butter knife. There you go. So that's nice if you want to use that. I mean, if that's the style, it's almost more sort of idiomatic in a way. Some people just have a preference and they're more comfortable with one type versus another. I don't see it as a real fundamental, mind-blowing advantage. So, but in any case, that's for you to decide. This is almost like essentially it does the casting for you. It's kind of like the way TypeScript will do the inferencing when it can. And so in the JavaScript world, the TypeScript world, it's very loose sort of system. It does have a typing system, but it's not really enforced. And so TypeScript will make an inference of the type, so you don't have to specify the type. If you can figure it out, it will. So that's kind of nice to have. And generally what I've found in the case of TypeScript, and I'm guessing probably the same with Kotlin, if it can't figure it out, you'll see immediately where the error is, meaning that it fails on simple stuff. And that's what you want, not on the super complex stuff, because, well, that's what it's there for, right? So, you know, it works out kind of nicely. And this kind of reminds me of JavaScript as well, TypeScript, no semicolon required. The interesting thing is, has anyone worked with Vue.js? It's interesting because there you cannot put the semicolon. And it complains, and the spacing is very, very strict. And it's sort of I'm going off on a digression here. It's a little bit tedious, but once you get used to it, it catches so many errors for you. Then you go back to this, it's a little bit looser. So you just have to learn the idiosyncratic behavior of the system that you're in. And they all kind of start to blur together after a while. They're all, yeah, more or less, you know, you can figure it out. One of the differences here is that variables are defined first and then the type when you specify that. And again, there are other languages that do that as well. It's a minor thing to get used to. Typically, what you'll find, again, support for the various numeric types, primitive types, and the operator precedence, conversion, and so forth. So here's a simple example of hello world. At the top, it's in Kotlin, and the bottom, it's in Java. Notice how much more succinct it is in Kotlin. You don't have to say public class hello world. It's just fun, not even function, fun, main, args. There's no public static void main, it's just print, and you're done. So that can save you typing. And how many people here are adept at typing? If you type over 80 words a minute, the savings is not as significant, but if you kind of hunt and peck, obviously this is going to be more preferable to you. And they may even support code snippets as well, where you have certain keys and you bring in this, that sort of stuff. I haven't looked into that, but I wouldn't be surprised if it's either that or some plug-in extension that gives you, so it's even faster. Now, from the command line, this might look a little strange, but it's Kotlin C for Kotlin compiler, the name of the .kt file, which is the Kotlin file, and then there's a switch that looks a little bit sort of peculiar. It's specific to Kotlin, -include -runtime -d. Now, typically the -d is either debug or directory. No, in this case, it's the name of the jar file that's going to be generated as a result of invoking the compiler. And then, after you've done that, as you see in step 2, the file that's created, the jar file, is hello world.jar. You can call it anything, but for consistency, I think it's just easier to have it the same as the name of the class file. And then when you want to launch it from the command line, you just use the jar option with Java. And so java-jar, the name of the jar file, and then the name of the class minus the .kt extension. And in this case, if we look back, you see that all it does, it prints hello world, and that's what it does. Now that file, that jar file is like 800K. So you're getting a very, very large jar file to do practically nothing. So the startup cost is significant, but after that, it tends to increase sort of linearly. It's not like if you had 4 print statements, it's going to be 4 times as big. No, nothing like that. It's just going to incrementally increase, fairly small. And so just to give you a little variation here, you can do things like, I don't know if has anyone worked with C, C++? You remember the Args? It's an array of, and then there's you can, square brackets of 0, 1, 2, blah, blah. Well, this is kind of, you can detect the size, and then if it's only 1, then that means, if it's less than 2, it's 1, that means just the name of the class was invoked. And so it doesn't have any command line arguments. Whereas if it does have at least 1, notice how the syntax, it's a little kind of idiomatic, I guess. $ left curly brace, args, square brackets of 1, right curly brace. It's just the way the syntax works. So again, sometimes you have things that are not things that you probably are going to remember immediately. You probably have to go, like I do, go back 10 times and then maybe I'll remember. It's a small sacrifice, so to speak. So again, here's an example. In this case, this is the command line .kt file. And as you can see already, step 1, Kotlin C, step 2 is the generated jar file, and then step 3. Notice that it's invoked with in green. Just happened to use the word pasta. I think I was hungry when I was writing it. And then the output is just hello pasta.
Question for you in terms of the class. So, as Kotlin is programming, how exactly? So, in Java dash jar, and then you have the jar file name. Then you have a class.
That's the name of the class, the .kt file.
So it's just the name of the KT file.
Yeah.
So it's okay. So
correct.
The classes are basically whatever's in the file is in the
correct. Yeah. And just a little bit about variables. This is, again, looks more Scala-like than Java. There's var and val. And how do you remember which one it is? Think of what I do is I think of var as short for variable. Well, if it's a variable, it can be assigned and changed, so, which is the case in Kotlin. If it's val, it's like value. It has a value. It's like a const. You can't change it. And that's essentially it. So the var behind the scenes, there's a getter and a setter generated, and a val only generates the getter, and if you try to change it, you'll get an error. Now, another thing that's interesting is avoiding null pointer exceptions, which is becoming more prevalent, sort of, more common to see that. For example, in Swift, that was a big deal for a lot of people, and avoiding the NPE, null pointer exception, and the question mark, which is a meta character. Now, is anyone familiar with meta characters? I'm sure you are. You may not call them that. There's plus, there's question mark, plus, and asterisk. Asterisk represents 0 or more. Plus represents 1 or more. Question mark represents 0 or 1. So that is the correct meta character. It wouldn't be a plus or an asterisk. That would be actually incorrect, I mean, semantically speaking. And so, just to give you an example here, to kind of get used to it a little bit. See, in this example, there's a commented out a section. And the middle part, there's the val for x1 and x2, printing the values. If you specify the value type of a val, it's actually going to generate an error. So you don't specify the type when it's val. However, if it's a var, you can specify the type or not. I know that's a little sort of idiosyncratic. I'm not sure exactly why it is that way. That's how it works. And so now notice the 4 vars is with and without the type, and then the val down below without the type. And then you can just print that. You can write the code similar to the example you saw and just run that. So now Kotlin functions. Again, if the compiler can infer the type, it's optional. This tends to look more Scala-like to me, or more sort of Haskell-like than it does Java or other languages. The variable argument type, that's like var arg, if you remember that from the old C days, and then introduced also in Java. So you can return different types. You can, a unit returning type is like a returning void. And then there's single, multiple expressions. So here's an example where we have a function called print hello. Notice the name variable is of type string. It's optional, and it just does print hello. So obviously it doesn't return anything. Now we have an example of a case of something called triple, where it takes an integer and returns an int. There are actually 2 other ways to do that. The second way in the middle, notice it's defined in 1 string. So it's very terse and succinct. If you only have a return of an expression, you can do something like the middle. You can make it even more terse and just fun triple. It takes an integer type and it returns the 3 times that value. So this is a very nice compact way of doing things. And this may be, when you start working with ECMAScript 6 and 7, this is going to be a lot more common to see this kind of thing. So here's an example of defining 2 functions. One is a number function, string function. Those are just arbitrarily, semi-arbitrarily chosen. Notice here they're def. It looks like Python now, as opposed to function, func. And at the bottom, you notice the number func and string func. In both cases, it's going to just print A and B. So this example, slight variation. You can use default values, as you can with some other languages. And typically, as you would expect, in the first one, B would be assigned an integer, and in the second one is assigned a string. Now, Lambda expressions, these are essentially defining a variable that is a function. And if you recall, or perhaps you haven't, if you haven't worked with JavaScript, you can do something like var x equals function blah, whatever it is. The way to differentiate between the function and the invocation of the function is very simple. Var x equals whatever, if it's function, that's the definition. If you type x, round brackets, that executes whatever it is that is that definition. Similarly with Kotlin. And there are some differences and similarities between Lambda expressions in Java 8 and Kotlin. We'll just kind of skip over that part. That's not high priority for us right now. But here's an example. We have, in this case, it's actually a val. It's a read-only. So what does it do? It's called print hello world. It just prints a string, nothing more. So you know at the bottom, notice we have print hello world in round brackets. That will invoke whatever it is that print hello world is defined as, and it will execute simply printing that string. Another way of doing it is doing the .invoke method. I'm not sure what the difference is in terms of advantages or disadvantages, but they're there for in case you need to do that. Now let's take a look at something a little bit more with a little bit more meat to it. We have in our main function, we have greet takes a string type, and it's a variable user, and notice how it prints the string. It's going to be good afternoon, and then $sign. We saw that before, remember, with the Args type scenario? And so in the case of, as you can see here in the middle, we invoke greet with, again, there are round brackets, but we're passing in, specifying a parameter there. So it's going to print good afternoon, Sarah, obviously. In the second case, we have two arguments. First is a string, as you saw above with greet, and the second one is an int type. And now the arrow syntax. This is, you'll see this in JavaScript. It's called the thin arrow, or sorry, they call it fat arrow actually. And it's essentially replaces square or curly braces. And it's a syntactic sugar kind of thing to reduce your keystrokes in essence. And what does this do? It prints, in this case, notice we have $user is $age, which is just, it really sort of extends the idea of what we did in the first one, the greet Lambda expression. And then you have show age, we pass in Steve and 35. Fairly straightforward, kind of no real surprises there, right? It's again getting used to the syntax more than anything. Another example of an Lambda expression, you can, there's a ternary operator. Is anyone familiar with that? If you've worked in Java and other languages, in essence, this is what it's doing, is it corresponds to what you can do with a ternary operator to determine compare two numeric values and then return the larger of the two. This is how we can define a Lambda function called max that will do exactly that. So it's a little bit more verbose than a ternary operator. However, if you need to, you can do it this way. And you can do a min and various other arithmetic operators that are not, or functions rather, that are not built in. So you can see at the bottom the invocation, it's going to return the maximum, that's going to be 10. Okay, now, a little bit different, a little bit more to it. We have add1 and add2. Add1 takes two integers and returns an integer, that's inferred. Add2 takes two strings, returns a string. Notice here we have x1 and x2, they're both val, and we do print, works as expected. Now what about this? We've got add 1, 2, and 3. Add 1, we already did that. Add 2, we already did that. However, look at add 2. It takes a string and an any. So what does Kotlin do? It infers that the plus operator is going to be string concatenation because there's a string and an any can be anything, including a string, and knows what to do. However, in the case of add 3, they're both any. So what is the inferred interpretation of the value of the plus operator? What's it going to be? It's ambiguous, so it's an error. That makes sense, right? And you say, well, I want it to be an integer. Another person, I want it to be a string. Well, you have to specify at least one of those arguments as the type that you want. Does that make sense? I mean, at first it might seem odd, but it is the logical correct syntax and semantics, rather. So, function type is a little bit more, it's sort of, kind of looks a little bit like a Lambda expression, kind of. Vaguely, kind of, sort of, and you'll see what I mean by that. Essentially, what you're doing is, instead of just passing primitive types, such as a string, integer, and so forth, or arrays, you're passing in a variable that has a type as a function. So what does that do for you? It means that you can invoke a function where you can have like a number followed by a number and then a function that operates on two numbers. Then you can pass in a function to operate on the two numbers you passed in, and you can change that function, and you can do it all in one place. So there's a certain amount of encapsulation to some extent. If you look at it in terms of OOP, you're hiding the details. And giving it the ability to go through one central function that kind of manages what you're doing. And depending on the situation that you're in, what you're working with, it may or may not be useful for you. It depends on the application. So function types can be very simple. They can be things that take no arguments and return nothing, or no arguments returning a string returning input of string, returning a unit, which is essentially void, or taking an input of a string and returning a float, and various other things. So let's take a look at a simple example. It's not a function type. It's the typical scenario, and you can see it's just adding two numbers. And not necessary to do this. This is kind of overkill, but you'll see in a minute why we're doing it this way. So we have the function fn, takes in two integers, returns an integer, simply the sum. So when you invoke or define sum as the result of fn of 3 and 5, it's going to return 8. No surprise. Now, look what we have here. Now, see, before we had a and b, and now we've got this function called func. Note over here we had just a and b and returning an int. Now it's a and b function returning an int. Don't panic. We're just going to go through it one step at a time. So now we have val result is going to be invoke the thing that was passed in, the third argument, which is a function, and invoke that function with those two numbers that were passed in. For instance, here we have val type. Add is defined as, it's a function type. It takes two arguments of type int, and it returns the sum. That's what we did in the previous slide. We added two things, two numbers, and returned the result. So now, instead of invoking fn of 3 and 5, we're invoking fn 3, 5, add. So in this example, func is actually just add. So this here is add of a and b. Well, what's a and b? 3 and 5. So add 3 and 5. What's the result? Well, it's defined here. What does it do? It takes them and adds them. It's 8. A very long-winded way to add two numbers, obviously. But it's just to illustrate how it works. Does that make sense? Pretty much? This is very, very common in JavaScript. And unfortunately, if you have a Java background like I do, the transition was a bit challenging. And kind of not used to having functions as first-rate citizens. It takes a while to get used to that thinking. But it does have advantages, no question about it. Yeah, that's right. Good question. Can Java do something that Kotlin cannot? I don't know for certain. There may be some exotic things. Java 9 and Java, I think starting Java 8 supported Lambda expressions, and Java 9 also supports, and streams. And Java 9 supports streams, as does Kotlin. It's possible. I don't know for certain. There may be some exotic sort of situations or very trivial sort of scenarios. That's one of the things that when you do your kind of proof of concept prototype conversion, you'll find those sorts of things that you would need. And then, of course, you have to, can we come up with a workaround, what's involved, and so on and so forth. That's how you do your analysis, rather than just watching a presentation. So now, let's take a look at something, building on this kind of same thing. So we started with an int and an int returning int. Then we went to this one. It takes an int, and a function type returns an int. Now, let's go int, function that returns int, function that returns int. That's just adding another function. We're extending the same thing. Look at the difference. A and B are ints. Func1, look what we're doing down here. We've got add and sub. Look at what we have here. 9, 5, add. That's the first function. Func2 is going to be sub in this case. What is sub? It's something that takes two integers and returns an int and returns the difference. There's really no fundamental difference. It's a very, very simple extension of that, of what we were doing before. Just a little bit more to kind of follow. It's not immediately obvious what the answer is. But if you work inward from the inside out, func2 of A and B, what's that? That's sub of AB. So that's sub of 9 and 5, it's 4. So this first guy right here is going to be a 4. What about func1 of A and B? Well, that's going to be add 9, 5, that's 14. So this result is going to be func1 of 4 and 14. What is func1? Add again. Add the result, 18. So I would strongly recommend, if you're new to this, if you're not really totally, completely comfortable with it, work with some of these until you'll get a lot of the repetition in there. You'll get a lot more comfortable that way. It certainly that's how I did it. And add a third one and a fourth one until you just go nuts, until you're like, this is crazy overkill. Then when you come back to the simple stuff, it's like, hey, this is trivial. So just as a suggestion, it's worth your while to spend 30 minutes doing something like that. And so now higher order functions. Well, we started with the Lambda expressions, higher order functions, and then with other higher order functions. This is related to FRP, functional reactive programming. Has anyone had any experience with FRP? That you will find it's become very, very popular. It's actually very kind of a core integral part of certain frameworks like Angular, where you work with observables and you have intermediate operators and you have terminal operators. And essentially, it's kind of like deferred execution. One analogy that I make is if you have worked with C programs where you have an ESQL, embedded SQL, you'll have a string when you'll have a SQL expression, and it doesn't execute, it's just a string. But at the time that you need to execute it, you can essentially convert it to a SQL expression that's actually executed. So at that point in time, you determine when you actually execute it. And so the sort of counterpart, I guess, if you will, in FRP is it's not a string that has an embedded SQL statement. It's going to be an expression, typically with method chaining, where you're invoking different operators, and they're called intermediate operators. And the way that you actually make it happen to execute involves a terminal operator. And in the working with observables, it's subscribe. So when you do a .subscribe, that's when things start happening. So, and in the case of Java 8, I believe, you can use for each. That's also essentially a terminal operator in the Java. So there are differences that you'll encounter when you do it in Scala, Java, Android. But again, keep in mind the foundation for RX Android is RX Java, and what I was referring to before with FRP earlier is RxJS, which is essentially what is used in Angular, more or less. Okay, with that in mind, these are some of the types in Kotlin that support a variety of these. I think of them as intermediate operators. I always think of it in terms of RxJava. It's my base point, so to speak, and everything is kind of relative to that. So there's a whole bunch of them. Now, you might recognize some of these. Some of the common ones that you'll find, and they tend to have the same name, is filter, map, and reduce, and they're already there, and reverse, sort, and a few other ones. And so here's a simple example. We have nums as the integers from 1 to 25. Evens is defined as the result of invoking the intermediate operator, the operator filter actually, of nums, which is an array. And what does it do? There's this kind of behind the scenes operator kind of loop variable, if you will. It's called IT. And what does that do? It returns the numbers in nums that are even, and odds, the numbers that are odd. And when you see here, we have the for each, for evens and for odds. When you invoke that, what does it do? Here we have that arrow syntax again. Because for each of those numbers, you just want to print the value of that number. Well, that's the simplest way that you can specify that. Take n, arrow, print it. I mean, that's the minimalistic way to specify that. I mean, you can't make it any simpler than that. And that's how Kotlin will enable you to do that. A very simple example, obviously, but now we have the map method. Now, keep in mind the difference between filter and map. Filter returns a subset of the numbers in the original array, like in nums. It might return all of them, in which case it's pointless to use it. Just print the array. On the other hand, map takes the original structure, in this case an array, and returns a new structure depending on what you want to do with it. It could be a smaller list from the original, potentially, but generally it's going to be a different list. In this case, what does it do? It doubles the numbers. So we start with 1 to 5 and return the even numbers from 2 to 10. Now, you could get a sublist of the original one. For example, here, like I had 1 to 25, you could do something like mapping IT%2. That will give you the even numbers. But generally what happens is when you're using map, you're generally applying a function to it to produce something else, some kind of operation, whether it's doubling it or squaring it or cubing it, something that you typically have. Instead of invoking that function separately, you do something like this. And again, notice the syntax here, slightly different. Now we have, a little bit different. Here we have println $n. I believe that works. I have to go check that. So what happens when you combine filters and maps? This is an important point to look at, whether or not you can reverse the order of filter and map. It might seem like you can. Maybe you can. Maybe you can't. The way to find out, try it and see what the result is. So in this example, we have nums 1 to 5. Filter takes the even numbers, and then map will then multiply those by 3. So what will the output be? Well, the even numbers from 1 to 5 are 2 and 4. Triple them, 6 and 12. So what happens if we take, let's say, the numbers from 1 to 9, and x in this first, the upper half of the slide there, it takes the numbers that are divisible by 4 and then squares them. Well, the numbers between 1 and 9 that are divisible by 4, 4 and 8, squared is 16 and 64, as you see. Now let's reverse that. The numbers from 1 to 9, you mentally don't need to compute the square of them because it's down on the bottom. You see on the right? Those are the squares. Now, take those numbers and filter them by the ones that are divisible by 4, and what will you get? Obviously a different list. You get not just 16 and 64, you get 4 and 36. So this is just a simple example to show you that you can't always reverse them. Why is that a concern? Because for optimization, for performance, if you can, generally, even if it gives you the same result, obviously, if you can do the filtering up front first, it's better. Think of SQL statements. When you do a join of some kind, if you have this complex set of clauses, you want to sort of return the smallest set first to filter out the maximum and then operate on those, and not this massive list and then operate on them. For example, you might have an operation that returns a million numbers and then returns filters by the ones that are multiples of 100,000. Well, it's only 10 numbers, right? You don't need to bring in that the million numbers. So there are cases where you want that if you can. If you can do so. If you can't, well, then you can't. It's just something you have to live with. So now, reduce. You may have heard that in combination with MapReduce. Remember, big table stuff Google was doing. I think it was a paper in 2007, I think, or 2006. I don't remember. Jeff Dean, the guy with Google Brain, he was the guy who was involved in big table and so forth. So what this does is essentially gives you a way to add the numbers from 1 to 5. And so there's no sum variable that's initialized to 0. It's just kind of set behind the scenes for you, which feels a little bit confusing at first, but it just kind of does that. However, if you don't like that sort of behind the scenes stuff, you can use fold, where you're explicitly initializing the result as 0. And you can set it to something different if you want to. So those are a couple more things that you can do. Now, I just want to do a little bit of recursion. And everyone's worked with that. So the interesting thing about it is you can have a recursive way to solve a problem, and there's an iterative solution. The sort of the expressiveness of the set of recursive solutions and the expressiveness of the iterative solutions is actually the same. That's not obvious. And it's not always obvious how to go from a recursive solution to an iterative one and vice versa. And you don't necessarily want to. For example, in case you haven't worked with it, the Tower of Hanoi problem, I would never try to write an iterative solution for that. It's just perfectly suited for recursion. Sierpinski triangles, Mandelbrot sets, you gain really nothing by trying to write it recursive in an iterative fashion. So do whatever makes it easiest in terms of the code to write the code, debug the code, and maintain the code, like everything else. So I'll just give you some examples of the iterative solution and the recursive solution of certain problems in Kotlin. So how do you add the first n integers? Well, if you look at the bottom, that's the closed solution. You don't even need to go through a loop. The sum of the first n numbers is n times n plus 1 over 2. So what's the sum of the first 10 numbers? Well, it's 10 times 11, that's 110, over 2, 55, right? Pretty simple. What's the sum of the first 100 numbers? 100 times 101 and divide by 2. Okay, well, it's 50 times 101. So that's 50-50. 5050. Right? These are nice little things you can do at cocktail parties, after people have been drinking. Hey, let's see who can do it. And then they'll think you're brilliant, perhaps. So, in the case of adding the first n integers, here we have the number in num is 5, and the result of the sum starts at 0. And we have a loop, and notice what we do is result is plus equals I. Very simple and straightforward. How do we do it recursively? Well, look at the only difference that's in between this and the only real difference. Notice we have num is 5 and result is to 0. Here it's going to be 0. We have this function here called sum, whereas there we have the for loop. What does sum do? It takes an integer, returns an int, and so if that number is less than or equal to 1, just return 1. Otherwise, return num plus sum of n minus 1. So it's going to be this kind of stack. It's going to return 5 plus the result of 4 plus the result all the way down to 0. And it's going to be a bunch of stacks involved, a stack rather, with a bunch of frames, and then produce the result. Not really particularly efficient. There's a way around that, which I'll show you a little bit later. What about factorial? This is the one I was actually alluding to. Notice here, so the three things, the key things are num, result, initialization, and the result in the loop. Well, look what we have here. 5, 0, and plus. The three things I mentioned, right? Here it's 5 again, 1 instead of 0, because it's a product. If you put 0, it's going to be 0. And then instead of a plus equals, it's times equals. It's essentially the same, right? For the iterative solution. What about the recursive one? It's again almost the same. Num is 5, result int. The result is going to be, look, we call fact. Remember, if num is less than equal to 1, return 1? Same. Return, and then instead of num plus sum of num minus 1, it's num times fact of n minus 1. Barely any difference at all in this case. Fibonacci numbers, now we have two sort of branches of recursion. You initialize f0 and f of 1, f of 0 and f of 1 rather, as 1. You don't have to, but that's typical. And then anything bigger than that, so n is at least 2, is f of n minus 1 plus f of n minus 2. So down below, look what we have. Again, almost the same. Result, f of num. Function takes a number, returns an int. If it's less than, num is less than equal to 1, return 1. Same. And now, instead of returning n times f of n minus 1 or n plus, num plus f of n minus 1, instead of that, we return f of num minus 1 plus f of num minus 2. That's it. So you always have a terminating condition, and then if it's not the terminating condition, the recursive step. Straightforward? Clear? Pretty much. And now you can do the iterative solution. And what I would suggest is, instead of, you can use an array. What's probably better is to use an array list. So essentially a dynamic array. And what you do is deposit the result. So the first element is going to be 0. Second one is going to be 0. What's the next one? The sum of the two previous ones. Excuse me. Sorry, it's going to be, my bad. The first two values are 1, not 0. So then the third value is going to be the sum, is going to be 2. Then 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3, and so forth, right? Now, what's the complexity of that solution? It's linear. Because you're just going through it. Every time you have a new value, it's just the sum of the two previous ones. The other one, the recursive, is going to be, what's the complexity of that? I'll leave that as an exercise, but it's not linear. The trade-off is, of course, your space. You're allocating, adding elements to an array list. So again, you know, when they ask you those structures type questions for those interviews, okay, here's the problem, but you're limited to this amount of data space and so on, all those constraints. So learning the variations thereof, or what's the advantage, what is the difference, explain. So that's a simple example of that. Generally, they tend to be more complex than this one, but you get the idea. And so, just to wrap this up, this is available as part of a set of videos, as part of a collection of free set of videos, and this is actually a subset of that set. So there about, right now we have 8 recorded out of 13 so far. And I took, I think, 4 of those and created this slide deck. So if you want to see it again, you can either watch the recording of this after it was posted, or you can go here and watch it in its entirety.